In this tutorial, we are going to learn how we can create longitudinal rebars of beams with Dynamo instead of in Revit. We're going to write a Dynamo script from A to Z, and because it is geometry heavy, we are looking at the basic geometry transformations in PowerPoint first. So let's get started. Alright, so before we jump right into Dynamo and start scripting, I just want to break down the geometry transformation that we're going to do in Dynamo because it's not going to be simple. So first off, we like our input is basically we have a beam, and our output should be that we want to optimize the longitudinal rebar creation with Dynamo. So what you can see here on the right. So how do we start actually? So we first going to start by selecting a front face. And from that face, we basically, like that face behaves like a cross section, and we can basically extract the curves, the perimeter curves, and then basically can offset those curves according to the rebar cover, and additionally the diameter of the stirrups. Now in the next steps, we are going to grab basically 2 points from those offsetted curves. That could be start point curves, that could also be end point curves, and it doesn't have to be necessarily those 2 points that are marked here. Then we select the whole beam and basically get the geometry into Dynamo and select no, we're not selecting a edge, but instead we're extracting the longest curve from that beam geometry, and through that we get the length and can do some mathematics to basically get the length of the longitudinal rebar. What we then can do is that we create a line, or 2 lines in our case, by start point and end point. And now maybe you're wondering how we can get from the length to those lines. And simply because we have this face here, we can basically get the normal vector in this direction. So with that vector and with the length, we can find out those 2 points back here and can create a line by start point, end point. And from that, we can create our first rebars from curve. And we also need to know the vector in which direction we want to distribute our rebar set. So that is the green vector in this case. And then lastly, we are creating from one rebar a whole rebar set. Alright, enough theory. Let's jump into Revit and Dynamo. And there we go. So we're having Dynamo here, and I already have prepared some beams in Revit here already, which you can see here on the right side. I always like to have Dynamo on the left hand side and then my objects in Revit on the right hand side, so that we can interact with each other, so we can select things but also see what we are changing. Alright, so before we're getting started, make sure you have the structural design package installed. You can install it here under packages, search for a package, and then type in structural design package here. Let's wait a few seconds until it's syncing. Yes, there we go. So structural design, and there we go. And then simply install latest version. I've done that, so I'm not gonna install it again. And now we basically can get started with what we saw in on the slides. So first we want to select the face, which we saw, to get our cross section. So we're going to select this face. We can also use another beam, it doesn't matter. And the important thing is here that we're gonna show how our script works for 3 different beams with different angles. Alright, so from that face we can get the parameter curves. Just type that in and connect it to our face. And I always like to show or see for myself actually what geometry we are creating. And we're creating lines and we can also visualize them. So if we go up here and then zoom to fit, we can see the geometry, which is now in Dynamo. Now if we just hide this, preview, then we can see that we now got our parameter curves. So from that, this is a little bit of workaround, as we already saw in the last video, but we cannot directly offset it. I can just show again. Curve, curve, curve. Where are you? Curve offset this one, because let's say we want 10 millimeters. Okay, let's make it 30 millimeters so we see it better. Yeah, so basically it's just taking the lines and offsetting it in directions that we don't want, and we need to control that much better. And one workaround here is that we are taking all the start points from those lines and then creating another rectangle and then offsetting again. So curve start point, let's just use those points, and then we're creating a rectangle by corner points. Must be this one. Connect them, run it. We can see that we now got our start point here, and we got now our rectangle as well. And now we can offset again. Run it, and now it's actually looking really good. Now it's still basically offsetting in the wrong direction, but we're gonna look at this now. So it is important for us to also get the rebar cover parameter from the beam in Revit. So in order to do that, we're gonna select model elements first. This is that one. And if you just have a look in Revit, what we want to get, it is this parameter here. We want to get those 30 millimeters here. Just this information. Going back to Dynamo, let's select our beam. And now we can get actually our rebar cover. There's again in the structural design package under properties. Let's find it. Rebar diameter. Nope, that's not what we look for. Cover. Rebar host cover, exactly. So we select our host element, connect it, run it, and then we just take a code block to take one output. And since all of the faces have the same cover, we can just take any of those. And now we can see that we got the 30. Now, since we most likely have also stirrups, we need to offset it even further. So stirrup diameter, but because we're just doing the longitudinal rebars in this video, I'm just gonna use a code block to assume the diameter to make it easier. But we can see in the next video how we can further automate that. So stirrup diameter, I'm just gonna say 20 millimeters. So we have the 30, we need to add the 20, but we also need to add half of our longitudinal rebar diameter. So we're basically now selecting which rebar type we want. Let's say H16, and from here we can get the information of the rebar diameter. So if we connect those two, we see that we get 16, and now we can add all of those together. So we say A plus B and then plus C half, which is the diameter. And now just put them in, and we should get 16 half, we should get 58 in this math calculation. Yes, and that's what you get. And now we just, yes, we need to have a minus here, because the minus is always offsetting inwards. This is just things that you learn when you use Dynamo more often. All right, so let's try it out. And there we go. It looks really nice. All right, and as we saw also in the PowerPoint presentation, we want to get some points from this rectangle now. So what we're gonna do is we're exploding the geometry. So then you can get actually the lines from our curve. And from here, let's run it first. We're taking yeah, let's just preview, and now we see it that it's blue. And now we can take start point, and select 2 of those 4. So I'm just gonna test for now which ones we're gonna use. We give the list a name A, and we want to get the information of the indices 0 and 1. So basically the first and the second items in here. So this one and this one. And if you just get the information, we want, yes, I think it's gonna be fine since they have different set values. So that means that we are grabbing one from the top and one from the bottom. Okay, so now this didn't work. I guess because we need to flatten the list first. Let's run it. Now it worked. Now we got the 2 points. Nice. Okay. So next off, we can just quickly go back to the presentation. What we need now, we have done this. The next step is going to be that we select the beam and get the length of the beam. We have already selected the beam, but now we can basically put the whole beam geometry into Dynamo. with the node element geometry. So just take the select model element, run it, and now we can see that the whole geometry is here. And once again, we are going to explode the geometry. And let's see what we get. We should get surfaces, yes. And now explode one more time so that we get from surfaces to lines. Okay, this did not work because we we need to flatten the list first. Flatten it. List geometry. Run it. Yes. No, this didn't work because we need not to explode the geometry, but instead, since we have surfaces, we need to get the perimeter curves. There we go. Surface. Let's delete this. And here we go. Now we can see that we got the lines. Okay, so from here we can flatten one more time to have them all in the same hierarchy. Run it, and then we want to get the curve lengths. And since we know that the longest value of the beam is usually, in most cases, also the longest, like the longitudinal direction is also the longest direction, we can actually extract the biggest value here, which is 12,000 millimeters. So let's look for a list maximum item, and then we should get the 12,000. Yes, there we go. And now we basically have the length, but usually you don't want to have the whole length, so we can do some math. Say the 12, the input, minus, yeah, maybe 100 millimeters. Okay, so now we define basically the length of the longitudinal rebars. The next step, as we saw in the presentation, is that we get this vector here, and that we then basically translate those points in this direction with the length of the longitudinal rebars. So first off, we're creating the vector from this face up here. Therefore, that is very simple. It's only one node, surface normal. Normal at parameter, simpler, since it is a planar face, we can just take. Alright, so the next thing we do with the surface a vector or surface normal at parameter, we're going to take this and put it into our geometry translate of our points. So let's just run this and see what we get. Remember, we had 2 points that were the input here. Okay, now we get everything rendered. And the output is now only 1 point. Let's see, here we still have 2 points, so we need to change the layers here and use layers. In this case, let's see if layer 1 works. and now we get 2 points. But let's see where they are. If we click on here, we cannot see any blue highlighted points. If we zoom out a bit, oh, we can see actually that there's 2 points over there. So basically the vector was in the wrong direction. Now what we can do, I'm just gonna see and select those. Yeah, and now they are blue and highlighted. But we can use vector reverse to actually reverse the vector, so that our 2 points are getting translated in the other direction. So we just take the direction, put it in vector here. We are using that vector and put it back into direction. Let's run that. And we can see that now our 2 points are successfully here at the end of our beam. Now, now we get 2 points actually, and now we can use those 2 points to connect them by line, by start point, end point. By start point, end point. We're just gonna use this node here. I think it doesn't matter right now which is the start point, which is the end point. Let's just use this list and this list, see what we get, and maybe we have to modify something. Okay, that is looking good. So what we now need, we need to transform those lines into rebar curves, and we do that with the node create from curves. We can also find them here under the structural design package, rebar create, and then from curves. Let's select that one. We get this one here. Take those lines here, put them in curves, and now we need some more inputs like rebar style, rebar bar type. Actually, we already have rebar bar type because we needed the diameter. So let's just see if this was actually the diameter. This is the right one. This is the longitudinal rebars. So we take that and put it in our rebar bar type. But now we need some more inputs. And most of those inputs you can actually find here in the package, but just because they say the name, it's easier to search for them. So rebar style, select that one. It's either a stirrup or a standard. We use standard here. No, that was my bad. Rebar style, rebar hook type, and we also need rebar hook orientation. So I'm just selecting both for now. Rebar hook, and now we can just select none. For now we don't want a hook for both start and end point, but this is an input you can always change. And then rebar hook orientation, since we don't have any orientation, we have to input something, so but it doesn't matter if it's either right or left. And then the last one, host element, we already selected that one, so that is our select model element. Take that, put it in here, host element. And then the last one that is now missing is a vector. And this is basically the vector in which direction our rebars should be distributed. And if we go make it a bit smaller, so Yeah, so what we can see here, if we have selected this beam, then we need to select either this edge out here or on the other side to actually get the normal vector in which direction we want to distribute our rebars. Okay, so let's do that. For that we can basically actually copy and paste the select face. Just gonna do that. Put it down here. Right now I'm just not sure which beam we selected, so I want to see that in my preview. We select that face. I want to see that one. Okay, I selected the wrong one, so I have to select this face here. And this is also something you can actually automate and include in your script when you select your select model element, your host. But this is for now quicker and easier, so we just do that. And then we have that face, so we want to have a normal vector of a surface. Normal, let's say surface normal at parameter. This one is what we're looking for. I'm gonna just input the surface, and then again, it doesn't matter which parameters we put in here because that face is planar. I'm just putting in the midpoint now. Alright, so now we can use that vector and put that actually in our rebar creation node. So put it in here, and now let's run and see what's going to happen. Okay, now we got basically one rebar, but we have two lines that we want to get. Okay, let's just delete that again. And I need to introduce basically levels, and I think it should be level 2. Level 2. And let's see at the input again, because if we often delete something, yes, then also the input is gone. Let's just select a rebar diameter again. And now let's execute it again. Yeah, so this time it worked as we wanted it. We got 2 rebars. And the next step is now to actually get the other rebar, so to get a set. Let's delete them again. And now let's just add the node layout set set layout maximum spacing. We could also have fixed number, we could also have number with spacing. I always like the S maximum spacing, but depending on what you do, you want to need different ones. So now I'm gonna select my 2 rebars. I want to have the input of a spacing. So let's say we want to have a number input here. Oops. And that is in millimeters. So for now we want a 200 millimeter. And again, this number could also be automated with calculating some distances between the edges, but again, we don't want to explode the scope of this tutorial, and also everyone has different use cases, so yeah. And then we are also needing the array length, and if you hop over that, it is basically saying the distribution length of the rebar set. And now we say spacing 200. What we could do, of course, we could just say the input, the spacing, since we only have 2 rebars in here, we could just simply say the 200 plus, I don't know, maybe 50, so that we get 250. Let's put that in and check our inputs. Rebar bar type, select that one, and now let's run it and see what we get. Alright, now we got something that I didn't expect or wanted, and we got basically 3 rebars here at the top and at the bottom. That is probably simply because we have this array length that is longer than the spacing, and we also have basically selected the set layout as maximum spacing. So within 250 millimeters, it had the maximum spacing of 200, but it's actually reducing that, in our case, to 125. But again, you can use different ones to achieve the result that you want. For this tutorial now it's fine, we just saw how we can actually distribute the longitudinal rebars, how we can create them from lines. And last video we looked at how we can do the same thing for our stirrups, and in the next tutorial we're gonna look at how we can actually put both scripts together and create one automated Dynamo player script that we can use now for 5 to 10, even 20 different beams. And then we can actually see how we can leverage our Dynamo skills. Thanks for watching, and I hope I see you in the next one.